Lesson 4, Understand chemical equations. Chemical reactions and conservation of mass. Chemical reactions occur when the particles that make up particular substances rearrange to form different substances. The substances involved initially are reactants. The new substances formed are products. Matter cannot be created or destroyed when a chemical reaction occurs. This concept is known as the law of conservation of mass. Because of conservation of mass, a chemical equation must be balanced. That is, it must have equal amounts of each type of atom on both sides of its directional arrow. For example, the chemical equation below represents the reaction that produces water H2O. 2 Hz plus O2 rightward arrow 2 H2O. The equation is balanced because the number of hydrogen H atoms on one side equals the number of hydrogen atoms on the other side, and the number of oxygen O atoms on one side equals the number of oxygen atoms on the other side. Types of chemical reactions. Various events can take place during chemical reactions. For example, in the chemical reaction that produces water, two substances combine to form one different substance. Chemical reactions can be classified by type, depending on what happens when they occur. Black circle in a synthesis reaction A plus B of, two or more reactants combine to form a single product. Black circle in a decomposition reaction of rightward arrow A plus B, a single reactant forms two or more products. Black circle in a single displacement reaction of plus C, another element in a compound. AC plus B, one element takes the place of. Black circle in a double displacement reaction of plus CDAD plus CB, two reactants form two new products. Oxidation investigation. Moistened steel wool is placed in a test tube. Then the test tube with the moistened steel wool and an empty test tube are placed upside down in a pan of water about 1/2 inch deep and set aside undisturbed for 24 hours. During this time, the iron Fe in the steel wool reacts with oxygen O2 in the air inside the test tube to form iron oxide Fe2O, or rust. Balancing chemical equations. Because the law of conservation of mass dictates that the quantity of each element does not change in a chemical reaction, a chemical equation must be balanced. That is, each side of a chemical equation must represent the same quantity of any particular element. The process of balancing a chemical equation involves determining the coefficients that represent the proportions of whole molecules in the chemical reaction. A scientist balances a simple chemical equation by inspecting the equation and, as needed, changing the coefficient for each chemical formula, beginning with the most complex formula. Ordinarily, balanced equations are written with the smallest whole number coefficients possible. If there is no coefficient before a chemical formula, the coefficient 1 is understood. As an example, consider the equation for the chemical reaction that produces water written as follows. It is not balanced because it shows two oxygen atoms on the left side and one on the right. To balance the oxygen atoms, a scientist changes the implied coefficient of 1 in front of H2O to the coefficient 2. Then the number of hydrogen atoms on the left side of the equation is 2, and the number on the right side is 4. So the scientist changes the coefficient in front of H2 to 2 to balance the hydrogen atoms, making the balanced equation for water. Changes in matter. Matter can undergo physical change or chemical change. When matter undergoes physical change, the molecules involved stay the same. When matter undergoes chemical change, the molecules change by breaking apart or recombining in different ways. The table identifies molecules of substances before and after changes in matter. Metals investigation. Small pieces of 3 different metals are placed in separate test tubes. Acid is added to each test tube, and chemical reactions occur. The products of each chemical reaction are a salt and hydrogen gas. Alkanes. Alkanes are a group of hydrocarbons. Highly combustible, they are clean-burning fuels with a wide variety of practical uses. The structural formulas below represent molecules of 3 common alkanes. Methane is the main component of natural gas. Butane is a fuel used in camp stoves and other products. Octane is an ingredient in gasoline. In the presence of oxygen O2 and a spark, alkanes burn to produce carbon dioxide CO2 and water H2O.